Hello, today we're going to go over section 3.2 review study guide. Starting with the vocabulary, there are only 4 of them. This is a very short study guide. Volume flow rate is the amount of volume of a fluid that flows past a point in a given time. Similarly, mass flow rate is the amount of mass of a fluid that flows past a point in a given time. Volume is the amount of three-dimensional space a substance occupies, and mass is the amount of matter in a substance. The short answer, volume flow rate is the ratio of fluid moved divided by the time interval over which it is moved. Typical volume flow rates are measured in cubic feet per minute, meters cubed per second, or gallons per minute. Mass flow rate is the mass of fluid moved divided by the time interval over which it is moved. And typical mass flow rates are measured in slugs per second and kilograms per second. On to the problems. Number 1. The pump on a fire truck allows a volume of 1,100 gallons to flow through it in 3 minutes. What is the volume flow rate of the hose? So volume flow rate is defined as change in volume over change in time. For this problem, we have a change in volume of 1,100 gallons being drained from whatever it's in, divided by the time it takes to change of 3 minutes. 1,100 gallons divided by 3 minutes is approximately 367 gallons per minute. Number 2. A rocket engine has a mass flow rate of 1,260 kilograms per minute. How long will it take to burn 12,000 kilograms of fuel? So we need to use the equation mass flow rate is equal to change in mass divided by change in time, and we need to solve it for time because it's asking us how long it will take. We multiply both sides by delta t, and we divide both sides by the mass flow rate. On the left-hand side, the mass flow rates cancel out. On the right-hand side, the delta t's cancel out, and we end up with change in time is equal to the change in mass divided by the mass flow rate. The change in mass that we're going to go through is 12,000 kilograms, and that mass is going to flow at a rate of 1,260 kilograms per minute. Kilograms cancel one another out. The minutes move from the denominator of the denominator to the numerator, and we have 12,000 divided by 1,260, and we get about 9.52 minutes for this mass to flow. Number 3 says water is flowing through a pipe with an inside diameter of 4 inches. The volumetric flow rate is 24 gallons per minute. Determine the mass flow rate in slugs per minute. Assume the weight density of water is 62.4 pounds per cubic foot. So the first thing that we have to do is change the weight density of water to regular density. Density is going to be equal to the weight density divided by 32.2 pounds per slug. So we're going to have 62.4 pounds per cubic foot divided by 32.2 pounds per slug. Pounds are going to cancel one another out. Slugs is going to go to the numerator. Cubic feet is going to stay in the denominator. And we are going to have a density of water of 1.94 slugs per cubic foot. So that takes care of our density. However, we also need to change the flow rate of gallons per minute to be in cubic feet per minute. So we have 24 gallons per minute that we have to multiply by 0.1337 cubic feet in a gallon. When we do that, we will get a volume flow rate equal to 3.2088 cubic feet per minute. Now we can use mass flow rate is equal to density times volume flow rate to solve for the mass flow rate in slugs per minute. So the density that we determined is 1.94 slugs per cubic foot. We need to multiply that by 3.2088 cubic feet per minute. The cubic feet will cancel each other out, leaving us with slugs per minute. And when we multiply 1.94 by 3.2088, we get 6.23 slugs per minute. Part B says, find the average velocity of water in the pipe in feet per second. In order to do that, we need to use the volume flow rate equation that says volume flow rate is equal to area times speed. Of course, we need to solve this for speed, so we divide both sides by the area, and we get that speed is equal to volume flow rate divided by area. Of course, this is a pipe, so the area can be found by taking the area of the cross section, and the cross section of a pipe is circular, so it's going to be pi r squared. We want the velocity to be in feet per second, so we need to have the radius of the pipe be in feet. We're given a diameter of 4 inches, so we need to divide that by 2 to get a radius of 2 inches. But to change it to feet, we need to divide that by 12 inches per foot. So making our substitutions, the volume flow rate that we have in cubic feet per minute is 3.2088 cubic feet per minute. We're going to divide that by pi times 1/6 of a foot squared. Entering that calculation into our calculator, we get 36.78 feet per minute. We all know that in 1 minute there are 60 seconds, so we have to divide that by 60, and we get 0.61 feet per second for the speed of the fluid moving in this pipe. For the last problem, we're looking at a boat propeller, and it is a 12-inch propeller, and as it rotates, it moves a column of water 8 inches backward for each revolution. If the propeller rotates at 120 revolutions per minute, we need to find, for part A, the speed in inches per second of the water. So the fact that it's rotating at 120 revolutions per minute means that it is rotating at 2 revolutions per second. Each of those revolutions, it moves 8 inches of water. So if we multiply 2 revolutions per second by 8 inches per revolution, we get a speed of 16 inches per second. In order to find the cross-sectional area of the column of water, we need to take the radius of the propeller and multiply it by itself and then by pi. So area is equal to pi r squared. The diameter is 12 inches, so the radius, of course, is going to be 6 inches. So we're going to have pi times inches squared. Of course, this means that it's equal to 36 pi square inches, but we care about the decimal more than the number in this class. So we have 113.1 square inches. For part C, we need to find the volume flow rate. That's going to be equal to the area times the speed that we just found for parts A and B. The area is 113.1 square inches, and we are going to multiply that by the speed of 16 inches per second. Inches squared times inches make cubic inches, and we have seconds on the bottom. 113.1 square inches times 16 inches per second is going to be approximately 1,810 cubic inches per second. Please let me know if you have any questions. I'm happy to help.